Okay. The period of an object performing a simple harmonic motion depends on the amplitude of the oscillation, the speed of the object at the equilibrium point, the initial position of the object. Okay. So the period time depends on what? So T equals, we know, 2 pi over omega. Okay. So the speed of the amplitude of the oscillation. Amplitude of the oscillation. Period time does not depend on amplitude of the oscillation. So this is wrong. That is, now for example, take a pendulum. Okay, a pendulum, normal one. You can do the experiment with giving us, like, for example, 4 centimeter displacement, or you can give 5 centimeter displacement. Get the same result. You do one set of experiment. You have to take, you give a small displacement. It will oscillate for like 20 oscillations. You get the time for 20 oscillations and divide by 20. You get the periodic time. Okay, and then using that, T equals 2 pi over L over G. So T squared equals 4 pi squared over G times L. This practical. So you can find this. You plot a graph against T squared versus L. From the gradient, you can find G. Again, you can do another experiment with, now this time each you get set of 6 readings. For each you give 5 centimeter displacement. Again, you get the same value for G. You can simply say same gradient you will get for the both graphs. So the period time does not depend on the amplitude. Also, it does not depend on the mass of the bulb. Okay. So the amplitude of the oscillation, no. The speed of the object at the equilibrium point. At the equilibrium, the speed equals a omega. So omega equals to v over a. So t is proportional to omega, and omega is related to v, the speed at the equilibrium. So therefore, statement B, right? So add the option. All A, B, C. The speed of the object at the equilibrium. Periodic time. T is only depend on 2 omega. Omega. The speed of the object at the equilibrium. Okay, so here, yeah. Now, if I give 4 centimeter displacement, speed of the equilibrium is some value. For example, it has a value, let's say V1. But if I give 5 centimeter displacement, it has V2, then definitely V2 is greater than V1. But this change does not affect for the periodic time, right? So therefore, this is also false. Okay, I'll ask you an additional question. Tell me, the energy of a simple harmonic motion depends on what? Amplitude of the oscillation. Yes. Yeah, the energies, the total energy is half Ka squared. Okay. So total energy is proportional to the amplitude squared. Now you may think E is proportional to K, right? But for a given type of simple harmonic motion, K is constant. We know that K equals m omega squared. In fact, K is a spring constant. It is a constant for a given type of oscillation. K is a constant. Now now for example, if you got this equation, instead of K, you have m omega squared A square. Now you may think that energy is proportional to the mass, but if you increase the mass, the omega decreases. If you increase the mass twice, omega, if you increase the omega twice, mass will has to be smaller by 4. Yeah, if you decrease the mass by 4 times, omega will increase by 2 times. Okay. Okay, a glass vessel of volume V is completely filled with a liquid of volume expansivity gamma 1. The volume expansivity of glass is gamma L. There is no theta. Yeah, even okay. Make a minus or a plus. There is a type mistake. Anyway, we'll see which is the correct answer. The glass vessel of volume V is completely filled with liquid of volume expansivity gamma L. The volume expansivity of glass is gamma G. Gamma L is greater than gamma G. That's obvious. No, glass is a solid. If the temperature of the glass vessel is increased by an amount theta, the volume of liquid that expels from the vessel is okay. So now I can write delta V for liquid. Delta V liquid equals V times gamma L times temperature increases theta, and delta V of glass will be V gamma G theta. So this change is smaller than this change. So therefore the difference amount will be expressed. So therefore the answer will be V gamma L minus gamma G over theta times theta. So answer is first one. Okay, question number 13. 100 millifarad capacitor connected in series with 10 kilo ohm resistor is connected to a 5-watt battery as shown in the figure. The charge stored in the capacitor at the steady state is okay. Volt divides between this and this. Okay. Is it microfarad? Yeah, here microfarad. So this should be microfarad. There are some typing. Okay, so here we want to find the charge stored in the capacitor in this circuit at the steady state. Okay, so at the steady state means no current is flowing. So here, let's say voltage V1, this V2, V1 plus V2 is 5 volts. V1 plus V2 equals 5 volts. Okay. So we want to find V1, so that therefore we can write Q equals CV. Okay. Yeah. Yes. So now current passing through the resistor. So this is equals 0. So therefore 5 volt is the voltage across this one. So 500 microfarad. 500 microfarad is 500. Micro is 10 to the power minus 6. 5 into 100. 500 microfarad. So let's divide this. So we have 10 to the power 5 into, okay, so we have 5 into 10 to the power minus 4. So 0.5 into 3. No, here 5. Second one is the answer. Figure shows two identical pulses moving towards each other along a string. Towards each other along a string. The two instances where the two pulses overlap completely, B, sometime after the overlapping occurs, are best represented by. Okay, so here has let's say amplitude A, this was amplitude A. Then when it completely overlaps, the amplitude will be 2A. So by considering this, the answer is A, this one or this one, 205. Okay. So after that, what happens? This wave again goes to this side. There is no any phase change. Okay. So the answer is second one. Okay. 4-point charges, each having charge plus Q, are fixed to the circumference of an insulating disk. Okay. 4-point charges, each having charge plus Q, are fixed to the circumference of an insulating disk of radius simple r as shown in the figure. When the disk is rotating about an axis passing through its center and perpendicular to its plane at n revolutions per second, the mean electric current along the circumference of the disk is. Okay, so current we know I equals Q over T. I equals Q over T. So we want to find the number of charges passing a point within unit time. So here it says n revolutions per second, right? So that means in 1 second, this charge, if you take only this charge, forget about this, this charge will pass n times this point. If you take this point, let's say P, this charge will pass this point n times per second. Since we have 4 charges, it will be 4 4 times. Okay, so the Q I equals Q over T. So the total charge will be NQ into 4 NQ over into 4 in 1 second. So the answer is 4QN. Third one. Question number 16. The concentration of water vapor inside closed room at a certain temperature is concentration of water vapor. So concentration, mass over volume, so density. At certain temperatures 24 point G, that means it's absolute humidity. H is 24 gram per meter cube. And the relative humidity is 60%. RH equals to 60%. If the air inside the room is made to saturate with water vapor at the same temperature, the new water vapor concentration inside the room is, okay. So we know RH is equals to M over MS into 100%. Okay. RH equals M over MS into 100%. So RH is 60% is equal the mass concentration I divide by V both sides. Okay, so you get density divided by density rho over rho s. So here this value is 24 divided by it's now density concentration rho s into 100%. So percentage and 0 cancel. So rho s is equals to 24 divided by 6 is 440. 40 gram per meter. Okay. So if the room is saturated, the AH is 40 gram per meter. If the air inside the room is made to saturate with water vapor at the same temperature, so no change in temperature, condition same, the new water vapor concentration inside the room is, okay, so we got the answer, 40 gram per meter. Question number 17. A metal block X of mass M at temperature 0 Celsius is made to contact with another metal block Y of mass 2M at temperature 100 Celsius. Heat transfer takes place between X and Y with an heat loss to the surrounding. Okay, so there is a heat loss to the surrounding as well. The specific heat capacities of the X and Y metals are Cx and Cy respectively. If the final equilibrium temperature of the metal block is 20 Celsius, then here's the answers. Okay, so we want to get the relation between C and Cy, Cx and Cy. So here, this should be no heat loss to the surrounding. It's no heat loss to the surrounding. So that is, this one is easy. The heat loss is equals to heat gain. So heat lost by Y. Okay, the same mass, right? No, metal block of its mass M. Y is 2M. 2M Cy delta theta. So 20 minus 100. Yeah, I'm just heat loss. Yeah, 100 minus 20. So 100 minus 20 equals mcx 20 minus 0. M cancel. 100 minus 20 is 80. 80 divided by 20 is 4. 4 times 2 is 8. 8 cy equals to cx. Do we have such answer? Okay, so the first one, cx equals 8 cy. Question number 18. The figure shows three identical bulbs which are being lit by a battery with zero internal resistance. The ammeter has a negligible internal resistance. If the if the filament the of one bulb breaks. So filament of one bulb breaks. That means no current flows through this. Okay. So I think we want to find the true statement, right? Okay. Ammeter reading decreases and brightness of each remaining bulb increases. The ammeter reading will increase. Ammeter reading will brightness of each remaining bulb. The remaining bulb intensity no, that is also not increases because same voltage. So the statement one is wrong. Okay. Okay. The second one. Okay. Ammeter reading decreases and brightness of each remaining bulb decreases. This is again wrong. By the way, what will happen to the ammeter reading? So here V equals. So here the let's say voltage is V, but here let's say R. So if we have 3R, the resultant will be R divided by 3. Okay. But if one breaks, the resistance will be R over 2. So we can put V equals IR. V equals IR. So R decreases, I increases. Okay. Ammeter reading increase and brightness of each remaining bulb. Where are the ammeter reading increases? No. Ammeter reading increases and brightness of each remaining bulb decreases. Ammeter reading decreases, brightness of each remaining bulb remaining the same. Okay, so the brightness is actually yeah, yes, R by no, R by 2. So this has increased, so I decreases. Okay, so I decreases. Now what happened to the brightness? If I decreases, let's say earlier it is, for example, 3 ampere. Sorry. Earlier, let's say it was 2 ampere. Or 3 ampere, let's say. So we'll go through this. But if the current decreases, then again current to the resistance will be same. Hold on. Mm. Mm. So I decreases, that is correct. So increasing ones we can remove. Okay. So we have brightness remain the same or increases or decreases. Okay. So දැන් මෙතනින් දෙන ශක්තිය එනර්ජි එක earlier consumed by 3. So now if you remove 1, this energy is given to only for 2. So intensity is increases, no brightness. So brightness current decreases. Now yeah, hold on. දැන් අපි මේ overall current එක අඩු වෙලා තියෙනවා. හරිද? But current through the each bulb increased or decreased? Wait. Wait. Now, if R increases, I decreases. Sir, I decrease when එතනින් V එනර්ජියක් දුන්නා නම් will hold on. It is the power output is given by Vi. Okay, so V is constant. Now I has R increased, I has decreased. So the current to this will also decreases. So therefore, brightness decreases. P equals Vi. So V constant. As I increases, so power I decreases. The current through each also decreases. So therefore, power decreases. Yeah, let's say अभी we got values for the डाल then here. Let's say this is 3 volts. Okay, and this resistance 1 ohm, 1 ohm, 1 ohm. So then current I will be. So I take each resistance 3 ohm, so that it will be easy. 3 ohm, 3 ohm, 3 ohm. Then if you consider the equivalent circuit, here you have 3 volts, resistance 3 divided by 3 is 1 ohm. So the current here will be in the mixed circuit is V equals IR. So I is 3 ampere. Okay. So this 3 ampere goes through each 1 ampere, 1 ampere, 1 ampere. Now if 1 is broke, so what we have, the this one EMF of the battery not change. Now we have the resistance 3 divided by 2. Equivalent is 3 divided by 2. So current will be V equals IR. So 2 ampere. Again still same 1 ampere goes through the battery, the remains the same. So මේක අනිවාර්යෙන් note එකක් දාගන්න හොඳට highlight කරලා මේ වගේ scenario එකක the brightness of the bulb don't change as both conditions the same current will flow through the each bulb. Okay. Yeah. Sorry. E equals V squared or R. Yeah. Okay. Here the variable changing is I, but R V is considered R. If R changes, yeah. Yeah. So the current through the bulbs also not changing. The current in the entire circuit decreases. Current to each bulb is not changing because V equals P equals VI. Okay. So the same brightness, same power output used by the each bulb. You can write this, if you want, write this numerical example. So here 3 volt, equivalent is 1 ohm. So current is 3 ampere. That means that 3 ampere current will go through each 1 ampere, 1 ampere, 1 ampere. And now if one is broke, so then we have only 2 resistors. So therefore equivalent resistor is 3 over 2. So then now you can use V equals IR to find the current. So you get current is 2 ampere. Then this 2 ampere only goes through again through both bulbs. So the voltage across the bulbs remains same, current through the bulbs remains same. Therefore brightness will remain the same. Done. Okay. And the next question number 19. Hmm? Pala here 25 we have on here. Oh, no. We can go up to 35. A force F 10 Newton is applied to the smaller piston P of area 2 centimeters squared of the hydraulic system shown in the figure to produce the force F1 on the larger piston Q of area 4 centimeter squared. When the surrounding temperatures decrease, the liquid inside is solidified. The solidified block moves freely inside the system and the new force produced on Q due to force F equals 10 Newton becomes F2. The respective values of F1 and F2 are. Okay, first we can write that pressure here is equals here. In a liquid, everywhere pressure exerted on the contain wall is same. So F over A. Now this is static. Okay. Yeah, that is for static. So here also we can consider static. Okay. So we have 10 Newton divided by area 2 centimeters squared. I'm not going to change the units. Is equals to F1 over 4 centimeter square. Centimeter square cancel. 2 into 1, 2 into 2, 20 Newton was F1. So the answer is second. In second case, it solidifies. So if you give here some force, same force only here. So 10 Newton. So this one also 10 Newton. So answer is the second. Question number 20. The figure shows a set of circles centered on a stationary point charge Q. The circles could be used to represent not electrical field lines, because field lines are, the shape of field lines, right? The magnetic field lines. So point charge Q, magnetic field lines, no. Yeah, their charges has to move. The magnetic equipotential line, there is no magnetic field, then how can be the gravitational field line, the electric equipotential line. The gravitational field lines also like this, the electric equipotential lines. Gravitation electric potential lines also can have. Gravitational field lines, if you take a mass, another mass, it will always points inwards. Yes. But here, if you have the gravitational equipotential lines, that is also correct. Okay, a small ball starting from rest rises through a viscous liquid and reaches its terminal velocity. Consider the following statements. The upthrust on the ball is greater than the weight of the ball. That is true. Otherwise, it should have fallen downward. At the initial movement of the motion, the viscous force on the ball is zero. That is true because initially the ball is at rest. We know the force is for a spherical object F equals 6 pi eta r v. V equals 0, F equals 0. The acceleration of the ball remains constant until ball reaches its terminal velocity. That is wrong. Acceleration starting from maximum value, it drops to 0. Start from a maximum value, it decreases to 0. When the ball becomes equilibrium, reaches the equilibrium. So acceleration becomes 0. At that instant, it will have a maximum velocity, which we call as terminal velocity. So then after that, it will keep moving with the constant terminal velocity. So only A and B are true. Okay. 10 persons are standing on a circle when one of them shouts. The intensity level at the center is 50 decibel. If all 10% shouts at the same time, each producing above sound level, the intensity level at the center becomes. So it will be, my guess is 60. Let's do and see. Okay. So the intensity level beta 2 minus beta 1 equals 10 log I2 over I1. So let's say we want to find the beta 2. Beta 1 is 50 equals 10 log I. Let's say initial I only one person, now 10I. Okay. So I and I cancel. Beta 2 equals this log 10 base 10. So that is 1. So 10 plus 50 equals 60 decibel. So answer is that. What is 10 to the power 5? Uh, By the way, this formula you can't directly use in essay paper. Okay. In essay paper, you can use beta equals to n log A over I naught. No? This is the formula you can use directly in the essay paper. If you want to use this, you have to derive it and show. You take beta 1 corresponds to intensity level I1, where I naught is the threshold intensity. Beta 2 equals 10 log I2 over I naught. So just take the difference, beta 2 minus beta 1. So here, beta 2 minus beta 1. 10 log I2 over I naught minus 10 log I1. Beta 1 is I1 over I naught. Beta 2 minus beta 1 is equals to 10 is common, I take out. Okay. And then log I2 over I naught. Log I2 minus log I naught minus log I1 minus log I naught. So here this minus and this plus, minus plus, that term cancel. Log I2 minus log I1. So, so here you get, I write this thing. So log I2 minus log I naught minus log I1 plus log I naught. So make beta 2 minus beta 1 equals 10 log. Subtraction means division. No? I2 over I1. Hmm? That's why I don't like online එක ළමයි සාමාන්‍යයෙන් අර interfere වෙන්නේ. Okay. Question number 23. Figure shows a PV diagram of a perfect gas, that means ideal gas, subject to a cyclic process ABCA. In this process, 3 joule of heat is absorbed by the system. Okay. 3 joule of heat is removed from the system. 6 joule of heat is absorbed by the system. 6 joule of heat is removed by the system. No heat is absorbed or removed from the system. So we want to find which is correct. So delta U ABCA is equals to what? 0. Cyclic process. So it is 0. So here they are referring heat, that is delta Q. Okay. And work done, delta W. How to find work done? Area under the graph. So they are asking about. So we want to find for the entire. Yeah. Delta Q equals delta U plus delta W for the cyclic process ABCA. That means you start from here ABCA. From here to here, delta U is 0. So therefore, delta Q equals delta W. Okay, so delta W we can find by calculating the area. Uh, so area will be area of this triangle. Okay, මේකට ගනකොට එක going side we have work done, the volume increases, work done by the system. So this minus, so you this area is minus this area, you get this area, triangle area. So half into 2 into height is 4. So 1, 2, 3 is 3. So it is 3 joules. 3 joule. If it's clockwise, delta W is plus, right? Delta W plus means delta Q also plus. So 3 joule of heat is absorbed by the system. This one is the answer. Okay. Question number 24. A photosensitive surface is illuminated separately by light of wavelength lambda 1, lambda 2 and lambda 3, where lambda 1 greater than lambda 2 greater than lambda 3. On a 3 occasions, the intensity number of photons incident per second of light used is kept at the same value. The current voltage characteristics of the photoelectric electrons for the 3 situations are best represented by. Okay, so the answer here, not this, not this, not this. Uh, we know if frequency high means stopping potential high, high frequency is to the low wavelength. So lambda 3 has to be this corner, answer is 4. So on all 3 occasions, intensity of the light constant. So intensity constant means this will go to the same point. Okay. Number of electrons ejected will be same, but the kinetic energy will change as the frequency is changing. So stopping potential is maximum for larger frequency. So the frequency is maximum, wavelength is minimum. So the fourth one is the answer. Okay, 6 resistors, each of value 50 ohm, are connected in circuit shown in the figure. The 10-volt battery has negligible internal resistance. The potential difference between P and Q. Here P, here Q is. So you want to find the potential difference between P and Q. So okay. So here we will simplify this circuit. Here 50, 50, and this side we have 50, 100. That is here, this here. So okay, so this 10 volt, here 5 volt. So I will make this easier. I will ground here. Okay. If you want, you can ground here. For my convenience, I'm grounding here. And also you can do this without grounding also. But when I ground this here, 0 relative to 0, it's easy for me to calculate. Okay, so Q value plus 10 volt plus 10 volt. එතකොට මෙතන මේ 10 volt එක සමානව 4ට බෙදෙනවානේ. මේ 10 volt එක මේ 4ට සමානව බෙදෙනවා. එතකොට මෙතන 2.5, මෙතන 5, මෙතන 7.5. So අපිට ඕනේ මේ දෙක අතර වෙනස Q එක 10යි P එක 2.5 7.5. Fourth one. I'll explain again. To make this ඇඟට වැදෙන්න ඕනේ හින්දා හොඳට තේරෙන්නේ මම මේක ground කරනවා. Ground කරාම මෙතන potential එක කීයද? 0. Here potential is 0. So relative to this point, here potential is 10. So this 10, that means this if you consider here, the 10 will divide equally. So here will be 5 volt. Okay. Because this entire thing is parallel with this one. So make a resistance like a සමානයි නම් සමානව බෙදෙනවා. මෙතන 5 volt, 5 volt, 5 volt, 5 volt. So total 10 volt. Hmm? Now it's like this now. If you take I'll read this part. So here you have this 10 volt. Here you have 5, 50 ohm, 50 ohm. එතන මොකද මේ 10 volt එක 5යි 5යි කියලා බෙදෙනවානේ. හරිද? එතන මෙතන බිඳුවේ ඉඳන් 5ක් 5යි volt. එතන 5යි ඉඳන් 5ක් 10යි. හරිද? ඒ වගේ දැන් මෙතන මේ 10 volt කියන එක මේ පැත්තේ in this side it divides into equal 4. So මේක හරහා 2.5, මේක හරහා 2.5, මේක හරහා 2.5, මේක හරහා 2.5. So බිඳුවේ ඉඳන් 2.5 is 2.5 volt. මෙතන ඉඳන් තව 2.5 5 volt, 7.5 volt. Okay. So now we want the difference between P and Q. Methana 2.5, methana 10. So the difference is 7.5. Okay. schools වල අර private class වලට classrooms දෙන්නේ නැහැනේ. මම මෙතන ඉස්කෝලේ එකක් දැහුවා. smart board තියෙනවා ඒවා දෙන්නේ. government regulation. But anyway they can make money. They can charge from each teacher. classroom 10ක් තිබ්බා නම් ගුරුවරුන් 10ට payment 10 ගානේ 10 ලක්ෂයක්. ඒක සුබ සාධන සමිතිය අර බැරි ළමයිට ඒ වගේ ගොඩක් දේවල් කරන්න පුළුවන්. Hmm? Yeah, voltage divider. Yeah, it's actually voltage divider only. Yeah, the voltage divider. So this parallel to this no මේ 10 volt එක මේ දෙක අතර සමස්තය බෙදෙනවා. 5 volt 5 volt. ඒ වගේ now these four are again potential divider circuit. So 2.5 2.5 2.5 2. Hmm. Great. Now what you can do is you can find here P potential value, okay, using that equation. But anyway, this is very straightforward, no, Mikramya? So it's 150 over 200. If you take this one, okay, so here let's say this potential you want to find P. So we divide by, yeah, voltage divide. So I take this, I want to find this voltage. V over 50 is equals 10 over 1, 2, 3, 4, 200. So this cancel, this is cancel. V equals 5 divided by 2, 2.5. And here this potential difference will be 2.5. Yes, from here to here, 150. Yes. Yes. Hmm. 26. Consider the following statements regarding alpha and beta particles. Both alpha and beta particles travel with the speed of light. Is it true or false? No. We know no object with mass can travel with the speed of light. To travel with the speed of light, the particle should have zero mass as a photon. Okay. So gamma is electromagnetic waves, so it will travels with speed of light. All EM waves travels with the speed of light. Okay. Generally, alpha particles penetrate deeper into materials than beta particles. That is strong. So alpha particles, due to three reasons, it penetrates less. One is it's heavier. The other one, its size is comparatively big compared to beta, so it can't penetrate easily. Three, Alpha particle has two plus charges. So ionization ability is double, twice that of beta. So it will quickly interact with the surface atoms. So therefore, due to these three reasons, it has very less penetration power. Uh, High ionization energy means low penetration power. Okay. Both alpha and beta particles can ionize atoms when they travel through materials. That is true. Yes, only C is true. 27. Which of the following figures shows the direction of the frictional force acting on the two tires of bicycle when it is paddled by a rider on a surface with friction? Okay. So the first thing that you have to notice that paddling is connected to the back wheel. That is the first thing you should understand. So the back wheel, when we paddle, what we'll do, we rotate this. So we rotate this also. We push the earth backwards. So therefore, equal and opposite force will acted on the bike friction. So then, due to this force, the bike is now pushed forward. So then this wheel is try to skid. So the friction force acting on the ground by the wheel is here. So equal and opposite force here. Second one is the answer. 28. An object of mass m moving on frictionless plane passes point x with a velocity v and rises up a frictionless inclined plane to point y, that is at height h above x as shown in the figure. If a second object of mass m over 2 passes the same point x with a velocity v over 2, the height of which the second object will rise is. Okay, so we know, uh, so we want to find the height. H equals v squared over 2g. So h equals, now v is v over 2 squared over 2g. So we have, uh, yeah, so we want to find new h1. So h1, h is this h1. Okay, so here 104 additional factor will come. So 104h. Okay. Since the surface is frictionless, energy conservation. By now, you should know kinetic energy is constant to gravitational potential energy. Height increases v squared over 2g. Similarly, v is equals to 2gh squared. These things you should know by now. And level of one don't know. Figure 1 shows a book A placed on top of a box B which rests on the floor. Figure 2 shows the free body force diagram for the box. Okay. PQR indicate the force acting on the box. Which of the following statement is true? Q is greater than E plus R. Q is greater than P plus R. Uh, Normally Q is equals to P plus R, right? But anyway, I keep this. We want to find the true statement, so this seems like false. Anyway, it's false. Okay. Force on the floor exerted by the box is indicated by P. Force on the floor exerted by the box is indicated by P. Wrong. Hmm? Yeah, acting on the box. Yeah, exerted on the box by the book indicated by R. O is correct. No? Q is less than P plus plus. This is impossible. Okay. This is possible if we consider the pressure due to air atmosphere. Okay. So otherwise, this wrong. So anyway, we have a good one. So we will have go with this. Yeah. So they are all acting on the box. A beam of electrons enters the region between two charged parallel plates. Okay. A beam of electrons enters the region with two charged parallel plates with speed 10 meters per second. මේකේ මම හිතන්නේ ප්ලස් නැත්නම් මයිනස් එකක් මෙතන තියෙන්න ඕනේ. වගේ මයිනස් තියෙන. Okay. So 10 to the power 6 meters per second as shown in figure. The potential difference across the plate is 200 watt. Magnetic field required to keep the beam along the y direction is okay. So we want to state if the electron is moving this direction, the electron negatively charged has a force. This electron. So this is Fe, electric force. So magnetic force is downward Fm, magnetic. So Fe should equals to Fm, right? Fe should equals to Fm. Okay, so Fe force equals Eq, capital E, electric field intensity Q. This is equals to BQB. Okay, so electric field intensity not given up. We have the potential difference. So E equals V over D. V over D, Q and Q cancel is equals to BV. Magnetic field, that's what we want. So potential is 200 separated 1 centimeter 10 to the power minus 2 equals D into V is 10 to the power 6. So D equals to 2 into 10 to the power 4 into 10 to the power minus 6. So 2 into 10 to the power minus 2. 2 into 10 to the power minus 2. So we have two options. We have to consider the direction. The field, we can use left hand rule. Current, magnetic field, force. Force this direction, electron moving this direction, current this direction. This is current, magnetic field, force. Okay, force is downward, and then current, electron moving this direction, negative charge, they have positive charge this direction. So field is into the paper. So fourth one into the paper. #31. An alarm is to be sounded in a car at least when the car is started while the door is open. Or the car is started while the driver is not wearing seatbelt. Three sensors A, B, C. An alarm is to be sounded in a car at least when the car is started while door open, or the car is started while the driver is not wearing seat. Three sensors A, B, C provide signals such that A equals 1 when at least one door is open, B equals 1 when the engine is running, and C equals 1 when the driver is not wearing belt. If the alarm is activated when F equals 1, the correct truth table. So A, B, C, A is A, door is open, door open. B is engine running, engine on. C not wearing seat belt, not wearing seat, no seat belt. Okay. The practical application මොනවාද? මේ B එක්ක A or C නානම් එක වෙන්න ඕන. Okay. So when B is 0, anyway it is 0. Uh, yes. So here B A B plus A or C, no? B plus A or means multiplication. No? I don't know. I forgot the Boolean which I get. When B is 0, the answers has to be 0. Okay. So you check the B 0 values. Make A burn 0 in order to make A in. So you can check it that which. That take all 5 B on the giving here. Yes. So here, so B 0 වෙනකොට මෙතන එකක් කියලා දෙන මේකෙන්. මේකේ 0 වෙනකොට 0, 0 වෙනකොට 0. Okay, this is sounds good. 0 0 0 වෙනකොට එකක් කියලා නෑ. You can check 4 and 5 also. So 0 0 0 0 0 0. 4 is also okay. මේක බිඳු බිඳුවයි බිඳුවක් බිඳුවයි. Okay, so we have three options again to run. Now B with what? A. No. B 1 වෙලා අනිත් දෙක බිඳුව වුණා නම් බිඳුවනේ. හරිද? So B with B 1 වෙලා A 1 වුණා නම් anyway now අර මේ options ටික පිටු දෙක තියෙන නිසා අමාරුයි. කලින් මොනවාද අපි අයින් කරපු ඒ ටික? හරි. මේකෙන් නෑනේ. මේකෙන් නෑ. මේ දෙක එනවා 2 3 එනවා. මේකේ B1 වෙලා හරිද? මේකෙන් නෑනේ. මේකෙන් නෑ. එක දෙකේ නෑ. So I put into mind එක දෙකේ නෑ. මේකත් එන්නේ. B0 වෙනකොට F1 වෙලා තියෙනවා. ඒතර එක දෙක තුනේ එන්නේ. හරිද? So we go to දැන් මේක ගත්තා නම් බින්ද 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 මේක එන්නේ. ඊට පස්සේ බලන්න B1 වෙනවා A0. මෙතන නේ මේකෙන් නැහැ. B1 වෙලා C1 වුණා නම් මේක 1 වෙන්න ඕන. So ඒ හින්දා 4 ඉන්නේ. Now let's check here. 0 0 0 0 0 1 0 නම් 0 අනිවාර්යෙන්ම 1 0 0 1 1 0 0 0 නම් 1 1 1 හරි. ඉතරේ පහ. 32. The potential divider circuit shown is powered by 30 volt DC direct current supply of negligible internal resistance. Okay. The potential difference across P and Q is 5 volt. P and Q is 5 volt. Yeah, 5 volt. So the value of the resistance R is. We want to find this resistance R. Okay. So මෙතන 30 හරිද? මෙයා පහයි නම් මෙතනත් පහයි. මේකත් පහයි volt. මේ 30න් මෙයා 25යි. හරිද? එතකොට 25 volts divided by 60 equals to 30 volts divided by no, I'll take this will be so 5 volts divided by either resistance. So we have two resistors R into 48 divided by R plus 48. Right. 1 over R equals 1 over R1 plus 1 over R2. So here we have 1 plus R2 plus R1 over 2 is take the reciprocal R1. So then I can do cross multiplication. Before that I can simplify 5 into 1, 5 into 5, 5 into 1, 12. So then we have here 48 R divided by R plus 48 equals 12 into 1 is 12. So here I have 48 R equals 12 R. 48 into 12 is 480 and 576. 76. Okay, I'll do MC. 48 into 12, 10 plus 2, 480 plus 96. So 96, 6, and 576. 576. So 48 minus 12, 36 R equals, we got this by multiplying 12 into 48. No? I keep that like that. I need to multiply that. So here 12 into 3, 12. 3 into 1, 3 into 3 into 3 into 16. So R equals 16 ohms. Potentiometer. Meter bridge. 33. The image of an erect virtual object which is situated between the lens and focus formed by diverging lenses. It is virtual, uh, virtual smaller than the object, because diverging lens, all the images are virtual. We can't get a real image from diverging lens. Okay, so therefore, this real all will virtual object. Okay, so virtual object again, but yeah, so it's now you have a diverging lens making මෙහෙම object එකක් තිබ්බනම් image will format the focus. Okay. So if I keep a object here, so virtual object, its image will form here because we call the reversibility of light. Okay, so here the image of an erect virtual object which is situated between the lens and focus. Okay, lens and focus. If I keep at f, okay, let's say this is the focal point. ඒකේ තිබ්බනම් මේකේ හරියට height එක භාගයක් වෙනවා. හරිද? එතකොට මෙතන තිබ්බනම් focus එකයි මේකයි අතරනේ. So if you keep here, the image will be not smaller, real and larger, real larger. Okay, real larger, and it is inverted of so erect virtual. දැන් මෙහෙම තිබ්බනම් මේක මෙහෙමයි හැදෙන්නේ. But it says image of an erect. Keep like this, then it will form like this. So real, erect, and larger than the object. That's one. So we keep erect, so the image also will be erect and larger than the object. So real object taking image virtual, virtual object taking image real. Reversibility of light. So real object, virtual image, virtual object, real image. Then මේ වගේ අවස්ථා there is no තනි එකක් එන්න. For example, if you have single lens, you don't get this because you have to have a virtual image. You should have at least two lens. So image of one lens becomes virtual. It becomes virtual object. Yes, yeah. So it's yeah, we can have a real virtual image from both no concave, convex convex. නෑ නෑ දැන් convex lens බෑනේ convex lens එකේ image ඇවිල්ලා real නේ හරිද අපිට ඕනේ virtual object එක. So virtual object එකක් ඕනේ නම් අපිට virtual image එකක් හදන්න ඕනේ. We want to form a virtual image. That image becomes a object to this lens. So if you have only one single lens, you can't have a initially virtual object. So you have another lens where it forms real image object එක image එක virtual කරලා දෙනවා. ඒ virtual image එක becomes a real that virtual image becomes a virtual object for this system update. Did you understand? Image is formed as same side, yeah, concave lens. So virtual image. So that virtual image becomes a virtual object for another lens. Otherwise, we can't take a virtual object now. Okay, 34. A monochromatic ray of light is incident upon a prism of refracting angle. No, prism angle, prism angle A and emerges as shown in the diagram. Consider the following statements made about the angle of deviation D. D is 0 when the ray enters the prism normally. As the angle I is increased from 0, the value of D passes through a minimum value. That is true. Okay. D is 0 when the ray enters the prism normally. It enters normally, okay, and then again will definitely meet another surface without normal. So there will be a deviation. So therefore this is wrong. For a given value of I, D does not depend on A. For given value of I, D does not depend on I. That again, now you keep this I constant and changing the side of this prism angle. You are increasing the prism angle, let's say. So if you increase here like this will come here. So definitely here the angle is different than this. So therefore this angle will be different. So therefore for given f D does not depend on of the statement. C is wrong, no? Only A is true. Okay, 35. The variation of the volume V with temperature theta of an ideal gas of mass m at a constant pressure is shown in the figure. So we can say PV equals nRT volume variation with temperature theta of ideal gas of mass m at constant pressure. P is constant, R constant, so mass n is also constant. Shown by the line edge. Sorry. Ideal gas of mass m at constant pressure P is shown by the line H. of the graph. The variation of V with theta of the same ideal gas of mass 2m at constant pressure P over 2 is sorry, this question. So EV equals nRT. Okay. So here V equals nR over P times theta. So the gradient is nR over P. Okay. So it says the variation of V with theta of the same ideal gas. So in the of mass 2m. So here mass is also changing. Then we have to consider convert n equals m over capital M. No? So this will be same, right? So here you can write simple m. Okay. So this is for H. Then we will write for uh, the new one. It says so V is equals mass 2m R P is P over 2. So here this will be 4 theta. So the gradient will be 4 times. So 2 නම් මෙතන මේ කීයද F G F no. So F plus 1. Okay, 36. The diode in the circuit shown has a zero forward bias resistance. Okay, normally we know silicon diode 0.7, germanium 0.3, but here this one have 0, ideal diode. Okay, has a zero forward bias resistance and a reverse breakdown voltage of 75 watt. Breakdown voltage of 75 watt. Internal resistance of the cell is negligible. The voltmeter reads 12 watts. When the terminal of the diode are reversed, the voltmeter reading is okay. So මෙතනින් එන current එක මේක හරහා යන්නේ. It doesn't flow through this. We go through this. So we can find the current. 12 and 2 V equals IR. So I equals 6 ampere. 6 ampere of current comes like this, and it's forward bias. Okay, so yeah. Now here comes 6 ampere. That 6 ampere. Here this zero resistance 2 to 3 ampere, 3 ampere, and then it joins 6 ampere. Now what if we reverse the diode? No current will go through this. This entire 6 ampere will go through this. Reverse voltmeter reading. Voltmeter reading. It doesn't change, no? So voltmeter reading 12 watt. Wait. Okay. So battery cell. What is the cell? It's not given, no? Okay. What are the options that we have? 6 volt, 8 volt, 9 volt, 10 volt. 15. So the diode in the circuit shown has zero forward bias. So zero forward bias. So no resistance. So 3 ampere, 3 ampere will go there. If we reverse, okay. So here then I can find 3 into 2 is 6. This is 6 volt. So totally 18 volts is the EMF of the battery. At the 6, 3 into 2 is 6. So voltage difference between this is 6 volt. So therefore මෙතනින් බැස්ම 12යි 6යි ඔක්කොම 18ක් සපයනවා supplied by the EMF of the battery. Now we are going to change the uh, huh? It's like you can think like a potential divider. මෙතන 18 volt මෙතනින් බහලා ඉතින් okay. Right now all this arrays now I have this value. Now I change this to other side. So no current pass through this. So here the current goes through this I. That same current only go through this I. So for this one, I can use the Kirchhoff. Okay, 18 volt equals I into 2 plus 2. So I equals 18 divided by 4, 9 divided by 2, 4.5 and 4.5 ampere. Now I can use this V equals IR. This into 2, 9 volts is the answer. Again, okay, sure. So here they give the information that this is 12 volt. So then I can use V equals IR for this to find the current. So then 12 divided by 2, 6 ampere is the current. So here it's 0 forward bias resistance. So both side resistance same. The current will be divided equally. This side 3 ampere, here 3 ampere. Okay. So for this I can use V equals IR, and then I can find this voltage difference is 3 into 2, 6 volt. So then the battery EMF is equals to total potential drops 12 volts plus 6 volt 18 volts. Yes, there is a potential drop, but I'm not using for this. I'm using for this. For this I'm using V equals IR. So 3 into 2, because it's a normal resistor, it's obeys Ohm's law. But let's say this is a essay paper, then you can't use for this. You can't say this potential difference using V equals IR. You can't get. So in that case, you have to mention and do here. Because since it's a diode, have a forward bias voltage, but that value we don't know, so we can't use for this. Okay. So now I found figure it out this 18 volt that I did all this. So now the reverse the diode. So now current through this, the current entire current I will flow through this. The same current will flow through this. For this loop, I can use the Kirchhoff. Sigma E equals sigma R. So sigma E 18 volt equals to I into 2 plus 2. Therefore, I equals 4.5. Make I 4 18 divided by 4 is 4.5 ampere. So then I want to find the voltmeter reading. So I into 2. So that voltmeter reading is 4.5 into 2, 9 volts. That is 7. Okay, a non-viscous and incompressible fluid flows through a tube in which the cross section is varying as shown in the figure. The variation of pressure along axis OX is best represented by cross section area with pressure variation. Okay, so according to continuity equation, Q dot pressure is not equal. There is a pressure gradient. Q equals AV. If A is large, this is constant continuity. So Q dot is constant for the flow constant. So therefore, if A A decreases, if A decreases, V increases. If V increases, pressure decreases, and all. Okay, so we have. I'll check the options. So A decreases, V increases, pressure decreases. Right? This cannot happen. It's like magical. This also can't. The answer is the fourth one. Question number 38. A uniform circular disc, radius r and mass m, rotates with a uniform angular speed in a horizontal plane about passing through its center perpendicular to its plane. The moment of inertia of the disc about the axis described above is half mr squared. When a ball of clay of mass m08 is placed gently on the edge, the disc, and if it sticks, the new angular speed of the system is. So here they are saying gently, meaning that no any torque is applied. Okay, so that we can use momentum, angular momentum conservation. I1 omega 1 is equals to explain, I will illustrate the problem. Uniform circular disk of radius R, mass M, rotating about the center. So another mass at distance R over H. Okay, so I can write I1 omega 1 is equals to I2 omega 2. I1 is half mr square. Initial angular speed is, I think, omega. What is the angular speed? It's given as, I can't find it in the omega. So half mr squared omega is equals to I2. Now the total moment of inertia about this is half mr squared plus the mass is at the edge. Sorry. So distance r, mass is m over h. Is placed gently on the edge of the disk. Sticks and new angular. Okay, so mass m over 8 into r square. So half mr squared omega, half mr squared common, take out. So 1 plus 1 over 4. So this is cancel. Omega equals pi over here omega 2, pi over 4 into omega 2. So omega 2 equals 4 over 5 omega. 4 over 5 omega. Okay, a ray of light traveling in water, refractive index N1, is incident on the air water boundary at critical angle. Okay, a ray of light traveling in water. So critical angle, it will go through this. See, this is water. Yeah, water boundary at the critical angle. When a layer of oil, refractive index N2, is floated on the water surface, the angle of refraction of this light ray in oil is a ray of light traveling in water, refractive index N1, is incident on the air water boundary at the critical angle when a layer of oil, when we put a layer of oil, when a layer of oil N2 is floated on the water surface, the angle of refraction of this light ray in oil is okay. So this is oil, air, water. So oil N2. So I can write N1 sine I equals N2 sine R for water oil interface. So N1, that is given as N1, N1 sine I. Here C, sine C equals N2, N2, N2 sine R, refraction of, we want to find R. So here I can, sine C I can write because here N1 equals 1 over sine C. That means N1 sine C is 1. This is 1, right? N1 sine C equals 1. So 1 equals n2 into sine r. So r equals sine inverse 1 over n2. Sine inverse 1 over n2. The value of the variable resistor R that minimizes the heat generated in the 5 ohm resistor in. එතකොට මේකේ the value of variable resistor that minimize the heat generated in 5 ohm resistor. මේක minimize වෙන්න නම් the best thing is meter bridge so that no current flows through this, right? So we'll consider here O3 meter bridge principle. Sorry, Winston bridge. Sorry. Yes, sorry. So Winston bridge. By the way, the meter bridge is using Winston bridge principle. Okay. So anyway, I should have mentioned as Winston bridge. I apologize. So we want to check for a Winston bridge. 4යි 3යි. මට මේක simplify කරන්න මෙයා 10 වුණා නම් එතන 5 වෙනවා. 5. Yeah, we want to get no current through 5 ohm. Yeah, the minimum value is 0. So I'm checking if I can get a Winston bridge here. මේක 10 දැම්ම නම් 10 option එකක් තියෙනවද නැහැ. දැන් අපි check කළාද? Less Winston bridges. R1, R2, R3, R4, R5. Okay. So if R1 divided by R2 is equals to R3 divided by R, then here and here potential will be same. So no current pass through this. So sometimes it says this divide by this or this divide by this. You do the cross multiplication. R1 divided by R3, R2 divided by R4. Okay. So I'm checking for. Yeah, we'll check whether we can. Yeah, because here we have this phi is this. Okay, this will be this. Equivalent will be this. And either resultant of these two or these two. No, resultant of these two is this. Okay. So here 3 over 4 is there. Should be equals to 12 over මෙතන කීය දෙන්න ඕනේ? 4 3න් ගුණ කරා 3 3න් 9. එතන 9 එන්න නම් කීය දෙන්න ඕනේ? Let's try to solve this. R into 10 over R plus 10 should equals to 9. Okay. 10R equals to 9R plus 90. Take this here. R equals 90. Yeah. Okay. It's time if you want. We'll do another 5 minutes. And then we're done. A potentiometer circuit is set up as shown in the figure. When the galvanometer is yeah, you get for the structured also. Meter bridge. Hmm? No, yeah, you have in the syllabus. Potentiometer circuit is set up as shown in figure. When the galvanometer is connected to point A and to point B respectively, the balance length of train are 75 centimeter and 300 centimeter. The ratio of R2 over. Okay, so the potentiometer principle is the potential difference is equals KL, right? We balance by a potential. Okay, so here it's when you put to R1, now when it sorry, connected to A, it's 75 centimeter. So now I say here this difference, let's say this potential difference balanced by, okay, so P equals KL is the potentiometer principle. So I say here point is something like P. So P E A equals K times the length is 75 centimeters. Okay. So this potential difference we can take VPA over R is equals to, I would say this V over R1 plus R2. So therefore VPA equals VR R1 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 over R1 plus R2. Okay, so then this is VR1 over R1 plus R2 equals K times 75. Okay, so then I put for B, connect for B, then V B VPB is equals to, here there is another resistor, no? I will see. So we will go for different. Uh, okay, so we can get it. Fine. VPB is equals uh, VPB over R1 plus R2. Here I take R plus R plus R plus R. So that is equals to K times, sorry, potential is then V over R1 plus R2 plus R. Okay, so I'm doing like this because recently I don't have enough practice. Yes, there is a short method. මේ කරගෙන යනකොට ඒ සමයට මට අල්ලන්න පුළුවන්. So then VPB is equals to VR1 plus R2 divided by, so I say this R total and right there. Okay, so then I can write this for the balance length V R1 plus R2 over R total plus K times 300. So this is where equation 1 and this is 2. I'm going to divide 2 by 1. So here in the 2 we have V times R1 plus R2 divided by R total. Divide by, and then we have V R1 R total is equals to k cancels 300 divided by 75. 300 divided by 75. So R total divides Vn. So we have R1 plus R2 divided by R1 is equals to 300 divided by 75 is 4. So R1 plus R2 equals 4 R1 make 9. So R2 over R1, we want the ratio is R2 R1 3. So if I have good practice, I would be writing only this R1 plus R2 divided by R1 is equals to K times 300 divided by K times 75, as this is proportional to yeah, because potential divider circuit proportional. Three hundred minus 75 or 75. Yeah, if you simplify that, you will get this here. K and K cancel. So 1 plus R2, yeah, R2 over R1 is equals to 300 over 75 plus 1 go to this side minus 1. So you get 300 minus 75 over. That's why we say practice is very, very important. Okay, so let's wind up from here, no? 41. So, කලින් පටන් ගත්තා නම් 50 ඉවර කරන්න තිබ්බා. Old, no? From 2009 or 10. And made it 50. All right. So those who have joined through online, guys, do you have any questions? Silent again, no? All right. So then for the next week, we'll discuss the remaining questions of this, and we have to, I'll give another MCQ for this year, 2005 actually. Then you complete this paper. All right, then see you on next week. Tata, bye bye. Bye.